It was still there. They checked again. It was still there. NASA engineers had been staring at the same transmission for weeks, running every diagnostic they had, eliminating every explanation they could reach. The data coming back from Voyager 1, a spacecraft more than 23 billion kilometers from Earth, was showing something that should not have existed in interstellar space. Not a malfunction. Not interference. Not the confused output of dying hardware. Something real. Something structured. Something the universe was doing in the darkness beyond our solar system that none of our models had predicted. And the deeper the scientists looked, the more certain they became that what Voyager had found was not a problem with the spacecraft. It was evidence of something impossible. This is not the story of a machine breaking down. This is the story of a machine that survived long enough to go somewhere no instrument had ever been, and measure something no physicist had fully prepared us to see. And once you understand what Voyager 1 actually found out there, the silence of interstellar space will never feel the same again. To understand why this discovery is so unsettling, you have to understand what Voyager 1 actually crossed. In August 2012, after 35 years of traveling through the outer solar system, Voyager 1 became the first human-made object to leave the heliosphere and enter interstellar space. That moment was not confirmed by a photograph or a visual landmark. It was confirmed by a change in the particles surrounding the spacecraft. The density of plasma, the electrically charged gas that fills space, shifted dramatically. Solar wind particles dropped away almost completely. Cosmic ray counts from outside the solar system surged to levels never previously measured in situ. And scientists knew that Voyager had crossed the heliopause, the outermost boundary where the sun's influence ends and the galaxy itself begins. It was one of the most extraordinary achievements in the history of human exploration. A machine assembled by human hands in the 1970s had entered the space between stars. But what the machine found, once it crossed that boundary, was not in any textbook. As Voyager 1 moved deeper into the interstellar medium, its plasma wave science instrument, one of the few still operational after nearly 5 decades, began detecting something that made scientists look twice. It detected plasma oscillations, vibrations in the electrically charged gas surrounding the spacecraft. The kind of oscillations that only appear when electrons in plasma are disturbed by a passing wave or pressure event. What startled researchers was not simply that these oscillations existed. It was how consistently they appeared and what they implied. They arrived in discrete, measurable bursts that correlated with solar events, coronal mass ejections from the sun, enormous releases of energy that sent shock waves outward through the heliosphere and beyond. Those shock waves were traveling through interstellar space and producing measurable plasma density readings around Voyager 1 at distances of billions of miles from Earth. From those readings, scientists did something that had never been done before. They calculated the density of interstellar plasma surrounding the spacecraft with a precision no instrument had ever achieved from that distance, and the result was immediate and striking. The interstellar medium was denser than expected, more structured, more responsive. Not a passive, static emptiness, but a medium with memory, with texture, with properties that reacted to disturbances in ways our models had underestimated. That alone should have rewritten the chapter. But then came something harder to explain. In 2021, a team of scientists publishing in the journal Nature Astronomy announced that Voyager 1 was detecting a persistent, continuous, low-level hum in interstellar space. Not a burst triggered by a solar event. Not a spike caused by a passing shock wave. A steady, unbroken plasma wave emission present even during periods of complete solar quiet. The frequency was approximately 3 kilohertz. Narrow band, stable, repeating. like a tone held by an instrument that never needed to breathe. Scientists described it as the background hum of the interstellar medium itself, a continuous vibration from the plasma between the stars, generated not by any single event, but by the ongoing thermal and physical properties of the medium. It was the first time such a signal had ever been directly measured from inside interstellar space, rather than inferred from a distance. And it had not been predicted by any model with any meaningful confidence before Voyager detected it. What this means is worth sitting with for a moment. The space between stars was supposed to be the quietest place we could imagine, the end of everything familiar, the beginning of true emptiness, and instead, Voyager 1 found that it hums, that it vibrates at its own frequency, that even in the absence of planets, stars, solar wind, and everything we associate with an active cosmic environment, the interstellar medium has a voice. And we had to send a spacecraft built 50 years ago to the edge of the known universe before we finally heard it. But this is the part where the story stops being only about Voyager and starts being about all of us. Because as scientists continued analyzing the transmissions coming back from Voyager 1, they identified something in the data that went beyond the plasma hum. There were fluctuations in the readings that did not correlate with solar events, did not correlate with instrument degradation, and did not resolve into background noise when isolated. They appeared to correlate with the regions of space through which Voyager was physically moving, as if the interstellar medium was not uniform, not smoothly blended across the void, but layered, divided internally into regions with distinct properties, edges inside the boundary, walls of denser material, pockets of compressed plasma, invisible architecture built not by our sun, but by forces operating at galactic scales. We had imagined the interstellar medium as a thin, relatively even gas filling the space between stars. What Voyager appears to be measuring is something with internal structure. Clumps and gradients shaped by shock waves from supernovae that exploded thousands of years ago and are still propagating. Magnetic field lines laid down by the deaths of ancient stars. Pressure from the broader galactic environment flowing around the heliosphere like a river bending around a stone. The interstellar medium is not an empty desert. It is an ocean, and it has currents we are only beginning to map. And then came the reading that made some scientists go very quiet. In data transmitted back from Voyager 1, as it moved through interstellar space at approximately 38,000 miles per hour, there were signatures consistent with the spacecraft encountering a region of significantly elevated magnetic field strength compared to the surrounding medium. Not extreme, not violent, but real, measurable, structured. A magnetic boundary embedded in interstellar space with no traceable origin from the sun. Scientists have described features like this as draping structures, regions where the interstellar magnetic field appears to wrap and compress against unseen boundaries in the medium, the way fabric drapes over a hidden object. The structure was not predicted at that location. The models did not show it there. The simulations had not placed it there. And yet Voyager was measuring it directly, in real time, from more than 23 billion kilometers away. Think about that distance for a moment. What does it mean in terms that the human mind can actually hold? A signal from Voyager 1 today takes more than 22 hours to reach Earth, traveling at the speed of light. When scientists receive a new reading from the spacecraft, they are looking at information that is nearly a full day old before any human eye sees it. When they send a command in response, they must wait another 22 hours for it to arrive. Every conversation with Voyager is already ancient history before the first word lands. And yet, from that distance, with instruments designed more than 5 decades ago, with a transmitter operating at just 22.4 watts, roughly the power of a refrigerator light bulb, this spacecraft is still sending back data that forces modern astrophysics to evolve. Here is the question that should stop you cold. What else is out there in that darkness that we have not yet felt pass? What other invisible structures, magnetic boundaries, and layered regions of compressed plasma exist in the space between our solar system and the nearest stars? What does the interstellar medium look like not from a telescope on Earth, not from a simulation on a computer, but from inside it, moving through it, feeling it directly with instruments that were never supposed to survive this long? These are not abstract questions. They are the most important, unanswered questions in heliophysics right now. And the only reason we can ask them with any precision at all is because one spacecraft refused to go silent. But the magnetic anomaly carries an implication larger than Voyager itself. And this is where the truly unsettling part begins. Our solar system is not sitting still inside the Milky Way. The Sun is orbiting the galactic center at approximately 448,000 miles per hour, carrying Earth and every other planet along with it. As it moves, the heliosphere, the Sun's vast protective bubble of solar wind and magnetic field, pushes through whatever interstellar material lies in its path. Scientists call the specific region of interstellar space our solar system currently occupies the local interstellar cloud. It is a warm, relatively low-density region of plasma and neutral gas that has surrounded our solar system for an estimated 60,000 to 150,000 years. The Sun is traveling through it, and models developed in recent years suggest that our solar system may be approaching the edge of this cloud. Some analyses indicate we could be within a few thousand years of crossing into a different interstellar environment entirely. One with different density, different magnetic field orientation, different pressure on the outer boundary of the heliosphere. When that transition happens, the heliosphere will respond. The boundary that separates our solar system from interstellar space will shift. The protective shield that deflects a significant portion of galactic cosmic radiation away from Earth and the other inner planets will change shape and possibly change strength. This does not mean catastrophe tomorrow. It does not mean danger next century. But it means the environment surrounding every living thing on this planet is not permanent. It is moving. It is changing. And the magnetic structures Voyager 1 is measuring in the interstellar medium near our solar system may be the first direct physical evidence of the environment that awaits us on the other side of that boundary. Voyager 1 may be crossing through the early edges of that transition right now, and we are reading its measurements with instruments built before most of the scientists analyzing them were born. What makes this even more profound is the irreplaceability of what Voyager is doing. Telescopes can observe interstellar space from a distance. Radio observatories can detect signals from across the galaxy. But no other instrument in human history has ever been physically inside the interstellar medium, moving through it, sampling it in real time. Voyager 2 crossed the heliopause in a different direction in November 2018 and confirmed that the boundary is not uniform, that the heliosphere is not a perfect sphere. That single comparison between two crossing points billions of miles apart was itself a landmark discovery. But two data points across the vast, three-dimensional surface of the heliopause is like measuring the entire ocean with two thermometers. It gives us direction. It does not give us the full picture. The Interstellar Probe mission, a concept studied in depth by NASA and the Johns Hopkins Applied Physics Laboratory, would send a dedicated spacecraft beyond the heliopause with modern instruments specifically designed for interstellar measurements. Scientists have proposed trajectories that could reach the heliopause in approximately 15 years using a Jupiter gravity assist and advanced propulsion, but that mission has not yet been approved for full development. It remains a proposal, a plan, a hope. And in the meantime, Voyager 1 is the only instrument we have inside interstellar space. The only one. And it is running out of time. NASA expects to lose the ability to operate Voyager 1's scientific instruments sometime between 2025 and 2030. The radioisotope thermoelectric generators, powered by the radioactive decay of plutonium-238, are producing less power every year. Engineers have already shut down heaters and non-essential systems to extend the mission. They have made extraordinary decisions, sacrificing some capabilities to preserve others, choosing which instruments matter most, knowing that every choice brings the final silence closer. When the last instrument goes dark, Voyager will continue traveling. It will keep moving through interstellar space at 38,000 miles per hour for millions of years. But it will no longer be speaking. There will be no final image, no farewell transmission, just a signal that one day does not arrive, and a silence that stretches all the way from Earth to the space between stars. That silence will be one of the most significant losses in the history of science. Not because Voyager carries sentiment, though it does. Not because it is the last of its kind, though it is. But because every day it remains active, it is measuring a place that no other instrument can reach. And every day it goes silent is a day that data is gone forever, unrecoverable, unrepeatable, lost to the distance and the cold. So, when the plasma hum arrived in its data, it mattered. When the magnetic anomaly appeared in its readings, it mattered. When the density variations suggested internal structure in the interstellar medium, it mattered. Not just as individual discoveries, but as reminders that every transmission from Voyager 1 may contain the last measurement of something we did not know to look for, something that changes the model, something that expands the map. The findings taken together do not point to equipment failure. They point to discovery, the most uncomfortable kind of discovery, the kind that does not hand you a clean answer, the kind that opens a door behind which stand 10 new questions, each one larger than the last. The persistent hum where there should have been silence, the magnetic structures where there should have been uniformity, the layered density variations in a medium we believed was featureless. None of it fits the old picture. All of it is real. And Voyager 1 is the only reason we know any of it. There is something almost unbearable about that. One spacecraft, 22 watts of transmitter power, instruments designed 50 years ago, sending back evidence that rewrites what we thought we knew about the space surrounding our entire solar system. There is no backup. There is no second instrument in the same location. There is no way to go back and collect the data again with better tools. Whatever Voyager measures before it falls silent is all we will have for decades, possibly longer. And it is already showing us that the universe beyond the sun is not the featureless void we imagined. It is structured. It is active. It hums at 3 kilohertz in the darkness between the stars. It has magnetic walls we did not predict. It has layers we did not draw on any map. And somewhere out there, 23 billion kilometers from the planet that built it, a machine the size of a small car is still moving forward. Still listening. Still sending its whispers home across a distance so vast that the word far loses all meaning. It carries a golden record with the sounds of Earth. Waves, wind, music, human voices. The heartbeat of a civilization that wanted, more than almost anything, to know what lay beyond the edge of the familiar. And now, at the very end of its operational life, Voyager 1 is answering that question in a way no one fully anticipated. Not with silence, not with emptiness, but with evidence that the darkness beyond our solar system is alive with physics, ancient, invisible, structured, and humming at a frequency we never thought to listen for. The universe did not wait for us to be ready. It never does. It simply kept doing what it has always done, building invisible architecture in the space between stars, maintaining a hum in the plasma that fills the void, pressing magnetic boundaries against the edge of our solar system's protection, moving through time and space with complete indifference to whether any small civilization on any small planet was yet advanced enough to notice. And then one day, a spacecraft we launched in 1977 crossed the final boundary and heard it, and sent the evidence home, across 22 hours of empty space, in a signal weaker than the noise of a single snowflake falling on an antenna. If that does not make you feel the full weight of what it means to be a curious species in an infinite universe, then consider the final question that Voyager's discovery leaves hanging in the silence. We found a hum we did not predict. We found magnetic structures we did not map. We found layers in a medium we thought was uniform. And we found all of it by accident, with a spacecraft that was supposed to last 4 years and somehow kept going for nearly 50. So, what else is out there? In the parts of the galaxy our instruments have never touched, humming at frequencies we have not yet learned to measure, structured in ways our models have not yet imagined, waiting patiently in the dark for the day we finally build something capable of reaching it. Voyager 1 did not answer that question, but it did something more important. It proved the question is real. It proved the darkness answers back. And it proved that the greatest discoveries do not always come from the most powerful machines. Sometimes they come from the ones that simply refuse to stop. If this kind of question keeps you awake at night the way it should, subscribe, because the universe is not finished surprising us, and neither are we. Drop a comment below telling us what part of this discovery hit you hardest, because the people who made Voyager possible spent their careers asking questions that everyone else thought were too big to answer. And the best thing we can do to honor that is to keep asking. Share this with someone who still looks up at the night sky and wonders what is really out there. Because now, thanks to one aging spacecraft and the scientists who refuse to give up on it, we know the answer is stranger, richer, and more extraordinary than we ever dared to imagine.